All right, just recap. Natalia. Flat bone is made by what process? Natalia? Can you guys hear me?
Yeah, can you hear me?
Yeah.
I'm
It's
not
either
sure.
intramembranous or endochondral ossification. What's the answer?
Intramembranous?
Intramembranous.
Intramembranous?
Very good. So usually the long bone, right, were made by, here's an example of long bone, made by endochondral, okay? And you can see how the end here, the condyle, it still remains as a cartilage. It hasn't been ossified. So it stayed here as cartilage. So if you look at the microscopic structure of, you can see, again, a nice word to know. Are you talking? Because I can't hear you. I am talking. Can you hear me now? Okay. So most of you seen this. A good word to know is the osteon. It's a functional units of bone. In the middle of the osteon is the central canal. You can see that. And perforating canal is within these are the channel that go through the compact part. Okay. Good word to know. I'm going to talk about osteocyte versus okay, the cells that you need to know. Okay. Um, Okay, so there are 4 different cells that you probably want to learn or know about. It's very important. Okay? There are called the mesenchymal stem cell. Sometimes people call them as or osteoprogenitor cell. These are stem cells, in fact. Okay, they're stem cell. Okay, so I'm going to call that MSC for mesenchymal stem cell. The mesenchymal stem cell will give rise to osteoblast. Osteoblast. Good word to know with osteoblast is they osteoblast, they lay down the bone. Right. Another important cell that you need to know is osteoclast, which does the opposite of this. Okay. Osteoclast. And what they do is they chew up a bone. So they play opposite of that. So sometimes, let's say that here's the osteoblast, and they lay down the bone matrix, okay, all around it. It's like, imagine the guy that putting, some kind of cement around himself, right? And then if you do it all around himself, pretty much all of this right here is cement, right? Or you can say osteoblast put down the bone matrix, okay, down the bone matrix, bone, I should say, these are all bone matrix. And we'll talk about a little bit bone matrix. 2/3 of bone matrix is kind of like mineral. A third of bone matrix is like collagen. But all these bone matrix around here, and it gets trapped. So the osteoblast that is trapped in here, that trapped osteoblast can be considered as mature osteoblast, also known as osteocyte. Yeah, osteocyte. Okay, so think of osteocyte as same thing as osteoblast, but they're mature. Whereas osteoclast is opposite, and osteoclast chew up the bone. And oftentimes, what the osteoclast does is it has this multi-nuclei. Okay? You cannot dismiss this. There are many nuclei. What happen is that they fuse together. The one cell they fuse together to become the gigantic cells. And this is one of the cells that I've studied with for many years. They're kind of like very similar to macrophages, and that is they chew up bone, they chew up something. Right? It's very similar to um, similar to similar to uh, macrophage. Okay. All right. See if I can go back. Okay, so the osteocyte is same thing as osteoblast, but they're mature. So osteoblasts lay down the bone matrix, so they get trapped, they become osteocyte, and it doesn't really show you well, but here's the osteocyte. It stays in this little things called the lacunae. I'm not sure why you don't have the volume. Can everyone hear me okay? It seems like my microphone is working. Yeah, thank you. So I don't know why you can't hear me. And in fact, the osteoblasts sort of like when they lay down the matrix, these right here was similar to intercellular connection, like a gap junction. So you guys should know that the correct answer for the strongest intercellular connection, like a spot weld, the answer is desmosome. So the cells are still hold together like gap junction, but if you put a lot of matrix around it, so these things extended out, right? So they still kind of hold together, and then it becomes these things called canaliculus. And so then this canaliculus sort of like have a little passageway up, right? So that all of these osteoclast, osteocyte inside can actually communicate with each other. And it's believed that my colleague is studying this, that some kind of movement, right, muscle movement or bone movement can stimulate these cells to activate them. So they're sitting inside. All right, so the osteoblasts lay down the matrix. What are the matrix? Well, the matrix are mostly of this thing right here. It's called calcium phosphate. I don't know if you guys know calcium is +2, phosphate is PHO3, 3 minus phosphate. So calcium phosphate, C3PH4O2, 2. So in fact, there's 3 calcium phosphate and 1 calcium hydroxide that forms this hydroxyapatite. So if you can say 3 molecules of this and 1 molecule of this, I don't think you need to know this formula, but just to note that if it's 3 of this and 1 molecule of this has 3 calcium, right? 3 of them has how many calcium altogether? 9. 3 calcium phosphate and 1 calcium hydroxide will be 10. So that's where you get 10 calcium. Okay. 3 of these phosphate, each one is 2, so you get 6, and then 1 calcium hydroxide, which is basically OH here. So that's just the hydroxyapatite, and that's the mineral part. So I guess for your part, think of what is a bone matrix. Well, a bone matrix composed of mineral, 2/3 of it is a mineral, and there is a protein component. 1/3 of that is this collagen fiber. And so earlier when I talked to you, what is a functional unit of bone? Karen, can you hear me now? Karen Smith?
I can hear you. Can you hear
Good.
me?
So what's a functional unit of bone? Do you know Karen Smith?
For support.
No, that's not the answer. Valerie, what's the answer? Osteon. Good, thank you. Now, this is an osteon with the central canal, right? So when I ask you those, remember, note these questions that I asked you, you might see them again. That's the central canal. So right now you're doing a cross section of it, right? But longitudinally, you can see that it just basically, like that. But the idea here is that here's a central canal, right? That these lamella plate that is surrounded it, one of them has collagen fiber goes this way. The one on the outside has the collagen fiber that goes the opposite way, like that. So there's a crisscross pattern. And because of that, the inside lamella plate, when it just a plate, just a nice thin areas of bone, has collagen fiber goes this way. The other one outside has collagen fiber goes that way, right? It has this mesh network so that it does give it strength. So bone is very strong for that reason. Okay, and I'm going to come back and I'll tell you these different lamella plate, and the three of them that you need to know: circumferential, interstitial, and concentric that you see here. These are concentric lamella plate. All right, so the cells and the bones are, we know that osteocyte, it's the same thing as osteoblast, osteoprogenitor, the same thing as mesenchymal stem cells, and then osteoclast, which, remember, chew up bone. That's the osteoclast. Here just shows you what they look like. Typically, bone in the inside of the bone is called endostem. In endostem, that way you might see osteoprogenitor cell here, or they become osteoblast. They get trapped, so you can see it's get closer, get trapped, so they become osteocyte. And here's multinucleated cells. That's a key word. Multinucleated cells with osteoclast. And they usually form a pocket here, and they secrete hydrolase enzymes. So that's also chew up the bone that you see there. And then on the outside here, almost like on the surface, near the periosteum, I guess, you will see these cells known as the osteoblasts, okay, which is actually chewed up the bone. So imagine that, your tendon that is connecting the muscle, and then if you contract and move, you're going to pull on that bone, and pulling that bone will stimulate this osteoblast to work more, to put more bone. So what does that mean? Well, later on, if you guys are going to have children, you want to enroll your children to, maybe in AYSO, just the Youth American Associations of Youth Soccer, American Soccer Youth Organization, I guess. I just know it as AYSO. So they can play soccer or baseball, or they can play whatever sport they want to do. But you have to, enroll them in some kind of activity so they can become active. By active, I mean if it causes muscle movement, it's going to pull on this osteoblast, and that's where you get long, strong bone. But if your children are staying around, play a lot of video game and stuff, sedentary, you're going to have weak bone. Okay. All right, so that's your okay. And the cell that I spent a lot of time studying, 6 year, similar as osteoclast, and this is what osteoclasts look like. The multinucleated stem cell secrete enzyme, and they dissolve the bone matrix, right? Here's a very interesting that I think you guys should know too. There are 2 hormones that regulate bone development. Okay, so I'm going to go back to this. So So two hormones that regulate bone development. And these are parathyroid hormone and growth hormone. Interestingly, there's two hormones that regulate blood calcium, level. Okay. These are, again, parathyroid hormone and calcitonin. Calcitonin. Okay. Now, these two is very important because you will find that parathyroid hormone is also known as PTH, okay? PTH, parathyroid hormone. And calcitonin is calcitonin. Now, the way that you should think of this is that PTH function is to increases the blood calcium, increases your blood calcium. While calcitonin function is to decrease your blood calcium. Right, so you can say, there's two types of cell that we saw, right? One cell is osteoblast, which makes the bone matrix, right? If they mix the bone matrix, do you think they're going to use up bone calcium, or they're going to use calcium or not? What do you think? And then osteoclast. These are two important cells, right? Okay. Let me ask you this first question. PTH function is to increase your blood calcium. Do you think the PTH function on the osteoblast, or do you think PTH functions on osteoclast? Which one? Richard? Is Richard here? Yeah, Richard. What's the answer? What do you think, Richard? Osteoclast. Very nice, right? Because basically PTH is going to stimulate osteoclast, chews up bones so you can bring up your blood calcium, for example, right? On the other hand, if the calcitonin is trying to bring down the blood calcium because you have too much blood calcium, which one of these does calcitonin has effect on? Osteoblast or osteoclast? Wei Feng? Valerie? Osteoblast, yeah. Because basically what you're going to do is that calcitonin stimulates the osteoblast. They're going to use the calciums in the blood and put it in the bone so then you can bring it down. Okay? And two of these will have opposite effect similarly on the kidney too, right? So I don't think we need to focus on that, but you are later on looking at the urinary system, and that is one of the ways that the calcitonin work on the kidney is that it stimulates the kidney to get rid of calcium, so that your blood will goes down. On the other hand, PTH will stimulate the kidney to take back the calcium and the hope is to bring up the blood calcium. Okay. Okay. Those are the two good hormones I think you can start learning. And another functions of the PTH is how you can increase your blood calcium is that it actually stimulates the small intestine to take back calcium, to absorb calcium, as you will. You want to have anybody have a question? Okay. So I guess, is it okay if we just go for another 15 minutes or so and then we end it rather than have a break? I guess I don't have any idea, no idea. Okay, great, thank you. Thank you. Okay, so this is just shows you more descriptions of what a compact bone. Alice, you have a question?
No, because I cannot send the message. I just raised the whole say yes.
I don't understand your question.
No, I just raised my hand to say yes.
Oh, okay, thank you. Okay, so compact bone. Compact bone, you can see here again, functional units of bone is osteon. Okay. The bone that I don't know if we didn't get to the lab, but if the lab, you see the bone, they're probably missing this area here. Okay. This is the connective tissues on the surface. It's known as periosteum. So you probably don't see that, but in human, there's a periosteum. Peri means around, osteum means bones on the outer edge. Okay. Perforating canal, also known as Volkmann's canal. I think a lot of you have seen that already in pictures and Connect. This is electron micrograph of, again, an osteon. And here's a lacunae. What kind of cell do you see in a lacunae? Alice, do you know what cells you find in the lacunae here? What kind of cell? Alice?
Lacuna.
Lacuna is the area. Karen, what kind of cell do you find in the lacunae? What cell?
I'm not sure. I don't know.
Oh, Abdul says osteoblast. Well, originally they're osteoblasts, but they get trapped, right? Yeah, they're osteocyte. Yeah, good job, Richard. It is osteocyte, so make sure you know that, right? The osteoblast, they lay down the matrix. They get trapped. Hmm? And Karen Smith, can you turn off your microphone, please?
I muted it. I don't think that was me before. It should be.
I see your thing is still on.
Yeah, because I'm connected by my phone, but I'm muting my phone so you don't hear my background, but you're on speaker for me.
Okay. Someone just asked me a question.
The other side.
What was the question again? My question is, what cell do you find inside the lacunae? And the correct answer is osteocyte. They start out as osteoblast, but they lay down the matrix and they get trapped, so they become osteocyte. Okay. Oh, and where would I? Again, just shows you more scanning electron micrograph to show you what the bone tissue looks like, central canal, lamella plate. And I told you, no, the three types of lamella plate. This is interstitial, not the one in here. This is known as concentric, okay? And circumferential is outside. Before we go there, let's look at this. Oh, and this also shows you, start learning these three different lamella plate, because I like to ask these questions. Lamella plate that is very outside, okay, this is known as circumferential lamella plate. Okay, so that's like their outermost of the bone. Okay. So if you have bones that look like this, kind of ugly bone, but they're out here, okay, and they go all the way around, circumferential. The one that is part of the osteon is known as concentric. All of this is concentric, okay? So you can say that. Yeah, concentric. Now, between the two osteon, this is between the two osteon, this is interstitial lamellae. There you go. There's three different types of lamellae. The one is between the two osteons is known as interstitial. If the one is part of the osteon is concentric. It's on the outer edge, like you see here. That's the circumferential. Think of it as like the circumference of the circle. So here's a circle. The circumference is the outer edge. So there's a circumferential lamellae. Now, the concentric lamellae here, inside here, the matrix, remember we told you the bone matrix has two parts, the mineral part, which is 2/3, and 1/3 of it is collagen. But this one shows you the nice, well, this is just basically concentric, this one here. This one shows you the nice crisscross pattern of the fiber. See how the one fiber, the collagen fiber inside is going this way, and the outer side goes that way. So that actually they crisscross. So then it gives you a nice, mesh of, so that you can twist your bone this way, that way, it still stay pretty solid. Okay, it doesn't break apart. Spongy bone, also known as trabeculae region, trabeculae, okay, spongy bone. Oh, so you here, trabeculae, and that's not the compact, right? So the question is, would you find osteon in spongy bone? Would you find osteon in spongy bone? Jessica, what's the answer? Jason? No. Good, Karen. No. Okay. Osteon is only found in the compact region, not spongy. Spongy, I'm going to show you, is trabeculae. So they're not packed together, but they're kind of like mesh network. All right. So here's what the spongy bone trabeculae look like. See this? All of that. This is all the spongy bone. Okay. And the individual of these is trabeculae. This is trabeculae of spongy bone. And if you look at an individual trabeculae, they're all kind of like a lamella plate right here. So in a way they look like osteon, but they're not, because there's no central canal here. There's no blood vessel. But there's a lamella plate. They kind of have a meshwork. This is also an area that you might see a lot of red blood cell development as well. So in general, we say that the bone marrow, and typically these are the region that all your blood cells are made. Okay? The iliac crest you see here, or the ilium involved in making the blood cell, the head of the femur, the rib, right, and the head of the humerus usually are involved in making the bone. Typically, the bones in the cranium do not involve in making the blood cell, unless, if someone has a crisis where they do not have enough red blood cell development, then they start making in the bones here, start making them. So in that case, we call it extramedullary hematopoiesis. I don't know, this might be too much for you. Extra mean more, right? Medullary. middle area means medulla. So in other words, in the middle of these makes the bone extramedullary hematopoiesis. Poiesis is a process of making red blood cell or blood cells. Sorry. So when red blood cell is low, and you need to make more red blood cell, and these area cannot keep up. This area will make it. Okay. And we can see that, and if this area is made it, then a child might have facial deformity, if you will. Okay. So where the area that is found to make these, the vertebrae, the rib, the sternum, also their pelvic girdle, proximal head of the femur, and proximal hairs of the humerus. So these area to think of where you might involve in making blood cell. We mentioned already intramembranous ossification. So if I can finish off the intramembranous ossification, I think that we'll be happy with end it there. Then. Or maybe another, I don't know. Okay, so good thing to remember. Any bone, if I ask you from the neck below, except the clavicle, that's the only exception, is made by this process, endochondrification, which means you start out with cartilage first, and then the cartilage will get enlarged, right? And then it get calcified, and then you get restructured. Whereas this one, you don't have cartilage first. You have these stem cell, mesenchymal stem cell, that get together and they started to make osteoblasts. Mesenchymal stem cell develop into osteoblast, and they lay down the bone, they form spicules, blood vessel enter, and they get your trabeculae, spongy bone development, and you get diploid. Okay. All right. So here are the steps involved in ossification. The step in making bone by the process known as intramembranous ossification. First thing that you see here is the mesenchymal stem cell that become osteoblasts. Okay, and then the osteoblast started to lay down the bone matrix. The key word here is spicule. The form spicule was these extension, and then blood vessels started to invade, and then essentially these osteoblasts that's still making bones around the blood vessel will get trapped the blood vessel in there, and then it forms as the spongy bone. And then it forms as a diploid. So the diploid is, here's a compact bone out here, here's a compact bone out there, and spongy bones out there. So you guys don't have this, but write this down. This will be like, most likely it would ask you, what are the steps, the correct order to make an intramembranous ossification, okay? So write this down. First step is mesenchymal stem cell clusters together, form osteoblast. Second step, osteoblast lay down the bone matrix, forms a spicule. Third is blood vessel enter the area. Fourth is osteoblast next to the blood vessels, lays down, forming spongy bone, and then you get remodeling that forms as a diploid. So think of diploid is the last part. Everyone got that already? Finish writing? Not yet, not yet. Good. So make sure you know the order. Okay. 2 questions. 5 steps involved in making involving intramembranous ossification, usually bone from the neck up. And then finally, before you leave today, any bone that from the neck down beside the clavicle is made in by the process known as endochondral ossification. Again, you start out with cartilage, and it calcifies. So, what are the cells that involve in making the cartilage? It's called Zhao. What is the cells called? Is out? Alice? Okay. The cells that involve and make the cartilage is chondrocyte. Chondrocyte.
Oh, okay, cardocyte.
How many times do I have to tell you guys that? Chondrocyte. Okay. So when we talk about endochondral, meaning inside cartilage. And so this is the steps that is involved. You start out with cartilage, that's fetal skeleton cartilage. And some of the cartilage will get hypertrophied, which means get really big, right? And then you have the invading of blood vessel, right? And osteoblasts will come in, and typically then you can get this ossification center. In the center, this is called primary ossification center. Primary ossification center. This is secondary ossification, and you can see at the end of long bone is still cartilage. So the first thing that you see is enlargement of the cartilage, and that cartilage then gets some calcify, and then blood vessel enter, osteoblast convert all that calcifies as chondrocyte, so that they become hard bone. And the last step is that there is restructuring, which is osteoclast choosing up the bone so that the bone can grow. So we study these mice that does not have any osteoclast, so the bone is actually cannot restructure. So the bone is kind of like rock-like. So we call that osteopetrosis, opposite to osteoporosis. Osteoporosis, you get, porous bone, but this one you get rock-like bone. The word petro means rock, as in petroleum mean that's where they get the gasoline or refined gasoline from petroleum, petro, from rock. So hence the name. Okay, and you notice here and that the epiphyseal plate in the middle is still there as cartilage, and that's where the way that long bone grows, that from these epiphyseal plate, one end has cartilage and the other end would be ossified cartilage. Okay? And we're going to study that next time. But what are the steps involved in ossification, endochondral ossification? Here they are. Okay, 6 of them. Start learning these, and that will be the end of today's lecture. Then. And then maybe the next time we meet, we'll have 1 more hour and I can finish up this system. So the 6th thing that you see here is the first thing is cartilage made out of chondrocyte that get big, okay, and they get calcified. Calcified means that get bones in there, calciums in there. You get the blood vessel invade into the perichondrium, so different from periosteum, right? Perichondrium is invading the cartilage, right? The root word chondrium means cartilage. And that pericardium converted to periosteum, which is bone. And then the osteoblast replaces calcified cartilage into spongy bone. And then the last thing is osteoclast. Restructure the bone, borrow out. Okay. All right, are there any questions? Okay, I'm going to stop the recording here.